Alright, now we know what pass by reference is in general, and we also know how pass by reference is represented in computer's memory. We're going to talk in detail about how pass by reference works in processing. For the time being, let's look at a couple of examples of passing arrays to functions and returning arrays back to the calling function. So maybe pause the video and look at the code that I have up on in my slide and try to see if you can pinpoint what this code is doing, and you should be able to understand exactly what this code is doing. What this code is doing is, first of all, we're going to have an array of float. We are calling function calculate sum. This function takes data by reference, so R is a reference to array data back in setup. And we're going to calculate the sum of all elements in that array. And please pay attention that when we pass data over to calculate sum, data could be an array of size 1,000,000, it could be an array of size 100,000. In this case, we're making it simple, it's just an array of size 3, so it could be any size. So what it does, we're going to have a float sum, and we're going to loop, go through the array, and add the elements one by one to sum, and finally we're going to return sum. So the return type of this function is actually float. The important thing to realize is that we are passing the array, we're passing our array data as a function argument, and this is basically being passed by reference. But in function sum, we don't really make use of the pass by reference property because we don't actually change R at all. So in this case, R is just passed and it's used as an ordinary variable. So if you program this in processing and you run it, it's going to calculate the sum of all elements, which is 45. So you can kind of think of R pretty much as an alias here. It's not exactly an alias in processing, but pretty much. We're going to talk about this in more detail, but R is basically linked to data. So there's a link between the two, and as long as you don't break this link, R accesses all elements in data and can change all those elements in data unless you break the link, and we're going to talk about how this link could be broken in a little bit. But for the time being, let's actually draw the memory diagram of setup and see how it works. So the setup goes at the bottom in memory. So in setup, we have data, and it has 10, 15, 20, indices 0, 1, and 2. And we have result, in which to start with is garbage, and we're going to call function calculate sum, and we send data. So this is function setup. This is function calculate sum. So remember, arguments go at the bottom, so R is here, and we said R is a reference to the array that's been passed here. So data is not actually copied over, but there is actually a link, and the link goes to the very first element. Basically, we're going to have sum, maybe I'll just use a different color, and sum originally is set to 0. And we're going to have I inside the for loop, and we're going to go through. So inside our little for loop, we're going to have I, and I starts with 0 and goes all the way to the length, and each time we're going to keep adding until we get sum to be 45. Now, what's important is when I say in here, when I say R index I, when I is 0, R index I is going to point, is basically looking at 10. When I say A, and then let's, and then I plus plus, so I is going to become 1. So then we're looking at R index 1. That means we're looking at 15. And then when I goes to 3, we are going to be looking at 20. So we add all of this, and sum is going to be, so sum is going to be 10 first, then 15, and then, sorry, 10 first, then 25, and then 45. So by the end, sum is 45. And we say return sum. So when we say return sum, calculate sum is completely destroyed. And this link exists no longer. Oops. So the link is gone. And sum is being sent back, and the result of calculate sum is of course saved in result. So result is going to be 45, and that's what's being printed back. So it's the link that exists between the two. Now, what's important is in this example, AR is just being used as a normal variable. We're not modifying AR at all, so we're not making use of the functionalities of pass by reference at all. Okay, so let's look at another example. Here we are returning an array by value. That means we are actually going to have a function that is going to have a return value of an array. So here, this function is going to return an array of integers. That's what this return value means. So this is going to return an array of ints. So maybe now, again, pause the video for a couple of minutes and make sure you understand what this function is doing. This function is called myAppend. So recall the append function that we used with arrays. This is pretty much the same thing. So this is a user-defined function. It's not as fancy as the append function. The reason is the append function would work for any type of an int, so it's been overloaded quite a bit. For any type of an array it would work, but myAppend function only works for arrays of integers. So it's a little bit less fancy, but nonetheless it does the same thing. So let's go through this function and see what it does. Actually, let's before drawing the memory diagram, let's actually quickly go through the function. So we have an array called data again. We're going to call this function myAppend. We're going to pass it data, which is going to be passed by reference, and we're going to pass it a value to be appended. Here we are getting the array. R is a reference to data, So R is a reference to data which is in setup. Basically how it works is that we're going to create a new array. The size of our new array is going to be 1 more than the old array, which happens to be R. We're going to copy the old array into our new array. We're going to add the value of the value to be appended to the end of that array, and we're simply going to send this back to the calling function. So temp is going to be it's going to be sent back to the calling function. It just shoots it back and it's going to be copied in data. This is a very important example, so please make sure you follow the memory diagram very carefully. So this is what's going to happen. We have setup. Setup is going to have data. Data contains 10, 15, and 20, indices 0, 1, and 2, and we're going to pass data to our append function. So my append is here, my append. Now here, what's going to happen is we're going to have function arguments, which is R. R is a reference to data, so we're going to link to data. And then we're going to receive value. So value is being sent by value, no pun intended. 30 is going to be copied into 30 is going to be copied into value, so we have 30. Then we're going to make a local variable temp. So temp, the size is going to be r.length. So r.length is the length of data, which is 3 plus 1 is 4. So the length of temp is going to be 4. It's going to use a different color for indices, 0, 1, 2, and 3. And inside, of course, it's all initialized to 0. Then we're going to have a loop that's going to copy all elements of the old array, which is R, into the new array, which is temp. So given that loop, I'm not going to show the details of the loop because everybody knows how it works anyways. So we're going to copy, so temp is going to be, let's use a different color. Temp is going to be 10, 15, and 20, and of course still 0 at the end. So the next line, I'm saying temp temp.length minus 1. That's going to take you to the very last element of an array, because temp.length is 4, and 4 minus 1 is 3. So you're going to go to index 3, and you're going to put value in there. Value happens to be 30 in this case. Then we say return temp. So notice here, we are not using our link here at all. We are not modifying R at all. So when we say return temp, the first thing that happens is this thing is going to shoot temp to be copied in data. So actually what happens is the old data is going to be destroyed because you're copying something to it. So the old data is going to be, so this is going to be destroyed. So data is going to be 10, 15, 20, and 30. This thing's going to be destroyed, and when we say return, this entire function is destroyed, and of course the link doesn't exist anymore. So as soon as you destroy this, the link doesn't exist, so that's all gone. When I say it's destroyed, so this old array, it just sits in memory. It's just that the computer doesn't keep track of it anymore, so it just sits in memory until it's overwritten. So this is all gone, and you end up with data which has 0, 1, 2, and 3. So this is what returning an array by value means. That means you're taking this array, taking temp, you're shooting it back to the calling function, and you're going to copy that array into the array that's expecting it, which is data. So the old content is gone, and you see the new content existing. So this is really, really important, and hopefully it's making sense to you. The output of the program, when you say println, is of course 10, 15, 20, and 30, because data has changed in memory.